Hello. Continue from the previous videos. Now it's 2018 Chemistry 11 Clip 006. 005, I went through the basic ideas of QM model, which is your revisions. And this particular clip, I would like to begin with a concept that we went through in a class. We learned this. We've been talking about what concepts called mole. Mole, if you still remember what I asked you to do in the class, which is equals to a big number. And this big number has its name called Avogadro numbers, and Avogadro numbers equals to 6.02 times 10 to the 23. So like 1 mole equals to one big number. This is what you should be kind of like inject in your head and memorize it all the time. Now, what do we do? How can we apply this particular concept? We try to use carbon as an example, and we also try to use sugar as an example. To use carbon, I try to explain it in a class telling you why do we use carbon. Because it's stable, because it has like mainly carbon 12, and it's easy to weight, and there's lots of other reasons for it. But guiding us to see carbon is actually the best reference elements that we can use to assign mole. What mole related to carbon? They are basically the beginning point of all these mole calculations, and we have to assume 12 grams exactly of a carbon atoms, or 12 grams of carbon, pure carbon. 12 grams of pure carbon. You will try to weight it on the scale. If you try to weight that on the scale, then you will find that that would be give you one big number, more type of like the number of molecules in there, and the number of molecules that you find in there would be 6.02 times 10 to the 23 Avogadro numbers. And these Avogadro numbers help us to kind of visualize what's happening for mole calculations. If we say carbon is 12 grams, and we know that carbon mainly is carbon 12. To compare carbon 12 to hydrogen 1, and probably carbon 12 has 6 protons and 6 neutrons, while hydrogen 1 only contains 1 proton. When it's 1 proton compared with those 12, you would find that in between each other, you would able to see 1 compared with 6 plus 6 is 12 there. And 1 hydrogen protons would equals to 1 grams. So by doing these assumptions, we can say each protons, if you have 1 Avogadro numbers of protons, it weight 1 gram. So this comes to our basic concept of all periodic tables. Our basic concept of all RAMs, I should say, the relative atomic mass. Remember, relative atomic mass is basically equals to the average of all isotopes. And this particular RAM would say that if you have like the chlorine 35 and the chlorine 37, and we have a particular percentage composition between that, 25% and 75%. So when you try to take the average of all the isotopic mass based on the abundances, you will find that the RAM of chlorine is 35.5. And what this 35.5 means is if you take the average altogether, and then you will find that for all chlorine molecules that you find, it would give you average of 35.5 bigger 35.5 of protons. So if that is the case, if you have chlorine atoms, but like it both contain like 35 and 37. You can't separate them. A quarter of them 35, a quarter of them a quarter of them 37, and three-quarter of them is 35. Then for each chlorine atoms, like in general, if you have a whole bunch of it, if you contain 6.02 times 10 to the 23 chlorine atoms, one quarter of them would be chlorine 35, and sorry, three-quarter of them would be 3025, and one quarter of them would be chlorine 37. So for doing simple calculations, we would be able to see that one would weigh 35 grams, but like, but is well, if we have one Avogadro numbers of Cl35, it would be 35 grams times the 75%. And then you will have, if you have one Avogadro number, if you have just one Avogadro numbers of it, and one quarter of them is 37, will be 37 grams times 25%. If you add them together, eventually you will find basically the relative atomic mass values 35.5. If you consider this contains all these chlorine atoms contains like 6.02 times 10 to the 23, a big number. We're going to change the RAM into another name. We call them molar mass. And molar mass has a symbol of big M. Some people try to say that big M, little m there, because later on in the course, you will find that you'll find something that's quite confusing as you have another term that you use big M as well. So M is very common using symbol in chemistry. So sometimes it's quite difficult to realize it, which one is which. But like, yeah, we have to, like, hopefully over the term, you're able to hear me say molar mass, mass, mole, number of mole, and all these terms that will help you to distinguish between each other. Now, what is molar mass? Molar mass means if I give you 1 mole of that particular molecules, then what is the weight of it? Sugar, set as example, a very big molecule is C12H22O11. So that sugar molecule, that's what we in the sugar block, contains 12 carbon, 11 hydrogen, and 11 oxygen as one big molecule. And if I ask you what is the molar mass of C12H22O11, and you'll find out, okay, I haven't learned it, but you can just assume the RAMs of C12H22O11, add them all together, would be resemble molar mass. The way to do it is quite straightforward, as we can do carbon is equals to 12 gram per mole from the periodic tables, and hydrogen is 1 gram per mole from the periodic tables, and oxygen is 16 gram per mole from the periodic tables. Different periodic tables have different accuracy. In year 12, we have the data booklet, and that data booklet is the ultimate one that we use because eventually you are going to use it in your exam. Then you'll find those like 12, 1, and 16 values in your data booklet. Some other books, like the fancy book, they say, or fancy periodic table saying that is 12.01, and hydrogen is 1.0 something, and oxygen is 15.9999998, something like that. I would generally ignore them because it's not in the course. And in your data booklet, it's 12, 1, and 16. I'll just use them. If you use them, you will find out the RAM of that would be equals to 12 times 12 plus 1 times 22 plus 11 times 16. If we add them all up, it would equals to 180 gram. If this is 12 gram per mole, I've got 12 mole there. 1 gram per mole, I've got another 22 mole, and 16 grams here, I've got 11 mole. And altogether, it means that one thing, if I have 1 mole of sugar molecules, and this sugar molecules, 1 mole of it would weigh 180 grams per mole. Okay, so find out this is important because we can use this particular concept to convert things between each other. There's a way to convert it because saying that if I give you 10 grams, I'll just make it a bit easier, 6 grams of pure carbon, then you can tell me straight away what would be the number of mole. So the amount in terms of the mole as a calculations. But the amount in terms of mole, you can also convert it into the actual number of atoms present in there. By doing that, and we know that in between that we need to have some information. 6 grams of carbon, how can I find out the amount in mole? The amount in mole would be divided by 12, because as 12 is 1 mole, 6 grams of it, just half of it. So 6 divided by 12 give me 0.5 of a mole. If we've got 0.5 mole there, how do I know how much atoms in there? And we find another value, and the values would be 6.02 times 10 to the 23. As 1 mole is one big number, we only have 0.5. Times it, then you will find that there would be half of it, 3.01 times 10 to the 23 atoms can be found in 6 grams of carbon. Going through this process, we can make that into a formula. The amount of mole, we have a symbol. We'll call them number of mole with the symbol of N. As I say, like the N here is different from the shell that we have before, but using the same symbols. So try not to get confused between each other. Then what do we call, like if I give you 6 grams of carbon, and we call this actual given mass. The actual given mass that you have, we use symbol m to represent. And what would be the unit that you use for it? The unit for making mass is gram. And the unit for measuring the amount of mole is mol, which is the shortened form of mole. And what would be the number of atoms? There's no symbol for number of atoms. So generally, we just directly say the number of atoms. There's no symbols for it. The number of atoms would be atoms at the end. The unit for that, like how many apples in there. Then the unit for that one would be atoms. Right? Now, if we have all this, what you would able to see is that one, number of mole can be calculated by the mass given with the molar mass. As the molar mass is 12 here, coming from the RAM of periodic tables. Right? You can see those relationships with each other. Then, what would be the number of atoms if you want to find out? The formula would be number of mole times it by big number. I would say Na. Na is the shortened form of Avogadro numbers, which is 6.02 times 10 to 23. By using these two formula, you are able to do all the equation you want. Now, if I want to find out number of mole, you can use N over molar mass. If I want to find out the actual mass, so let's say I give you the number of mole. I give you 2 mole of carbon. How heavy is it? Then you can use mass can be calculated number of mole times molar mass. Just rearrange between each other and you'll find the answer. And the last formula would be saying that the number of atoms can be calculated by number of mole times the Avogadro numbers. So what if I give you the actual number of atoms? Say I have 12 times 10 to the 21 atoms in it. So how do I able to use this and convert back to number of mole? Then, because the number of mole can also be calculated by the number of atoms divided by the Avogadro numbers, and you can also find out number of mole. The worst situation is, what if I give you the number of atoms? Then I ask you to find out how much it weighs. What is the mass of it? Then you have to go through two equations to do it. First, we have number of atoms, and we try to change that into mole. Then from mole, and we can convert that into the mass we have. The first equation that you use to make it into number of mole would be using the number of atoms divided by the Avogadro number. Then you find out the answer for number of mole. Once you find out the number of mole, then you use the number of mole times by the molar mass. You will be able to find the mass. So this kind of like conversion before and after, you only take a few equations, but you need to know what do you put, which one do you use to divide by the others. Remember, I give you quite a few exercise, so I will try to use a couple of example and put it up here. Then you will get a bit better idea. Yep, just try to crop all these questions with you. So for the exercise I gave you, there would be a few area that you need to do. You need to convert gram into mole, or convert mole into number of particles, convert number of particles into mass, or convert molecules into mole. So how do we do all these type of questions? If you would like to convert, what do we call them, mole in there, try to use what color do we want, maybe green. So you've got that ideas. Number of mole, which is the little n there. Okay, come on. The little n is number of mole. And you have a given mass, which is a small mass there. I would like to calculate the number of mole in 25 grams of helium. From periodic tables, helium weight 4 grams. So the number of mole is equals to the mass divided by the molar mass of helium, which is 25 grams over 4. When you have 25 grams divided by 4, and you will have the answer equals to 6.25. There will be 6.25 mole as your unit. As the answer. The things that you do for methane is we have to find out the molar mass of CH4 from the periodic table first, which is 12 plus 4 times 1 is 16 grams. So if 16 grams is the molar mass, then we would like to find out the number of mole. So I'm telling you, like, this sounds like very difficult initially, but eventually you have such a pattern that wherever you see gram, you put it there. And wherever you see a formula, you go to your periodic tables. It's 12.5 divided by 16 grams. And then we've got the answer, 12.5 divided by 16, which is 0.781. Done, finish. This is one of the easiest kind of question that you can do, is to convert the mass into number of mole. All you need to do is a periodic tables, and then you will find you'll be absolutely no question to find that out. All right. For this sort of question there, so if I give you the number of molecules, how do I know how many moles in there? So what should I do? As this one is your number of molecules or number of atoms. Just hang on a second. I've got a phone call. I'll come. Okay, let's keep doing. Yeah, just the phone come on with me. Yes, what do we do next? The one that we do next here is the molecules. So here I have the molecules. So if we have the molecules or atoms, We know that for 1 mole of molecule is 1 Avogadro numbers, and we have a particular number. If we've got number of molecules, sometimes people use number of atoms, but like this one is asking you number of molecules, then I can just divide up this one by Avogadro numbers, will give you the answer of number of mole. So let's say it's 3.76 times 10 to 25 molecules that you have. And for 1 Avogadro numbers is 6.02 times 10 to 23. How many Avogadro numbers do you have in here? So definitely it's about 3.76 divided by 6.02. From calculator, I've got 0.625. Just divide this first, and then 25 divided by 23 is 10 to the 2. Then I know 10 to the 2 is 100. Move it to is 62.5 mole in there. Or you can say the answer is 6.25 times 10. So which is, yeah, pretty much, I think it's not possible. I think that's way better answer, just 62.5 mole. As it's done, finished. You can go a bit further if like just changing the mass into the mole, into the like changing the number of particles into mass. So we try to consider this later. Then the third situation you do is to convert the mole into number of particles, which is also involved with our Avogadro numbers. So for number of mole that we have, if we times it by the Avogadro numbers would give you the number of atoms or number of particles or number of molecules. This one is asking you, they only have like neon, so that would be the number of atoms that we have. 2.5 times it by 6.02 times 10 to 23. Then we have the answer with my calculators. 2.5 times by 6.02 give me 15.05. It's 15.05 times 10 to the 23. To move 1 across, you can also answer this question. Is 1.51 times 10 to the 24. And that's your answer. Remember, this one, you have atoms at the end, as neon is just atoms, right? And iron is pretty much the same thing. We've got the number of mole times by the Avogadro numbers, then is 0.05 times by 6.03 times 10 to 23. So you will also ask me like sometimes sometimes you need to use periodic table, sometimes you don't, because the only time that you use periodic table is you would like to have the molar mass. By looking at the formula, the number of mole can just able to find out by the number of mole times Avogadro numbers. So we don't need the molar mass at this point. The molar mass will be used by the next situations. So give you the answer for this 0.05 times by 6.02, which is 0.301. So we've got 0.301 times 10 to the 23. Move this across would be 3.01 times 10 to the 22. As is the answer. Okay. So hopefully you know this by heart with all these scientific notations. I can't help you with it because you should do math, right, with it. Now the last one would be the worst situations that we do. I ask you the mass, but I only give you the number of atoms. Then you have to separate this into 2 steps. First step, you have to find out the number of mole, then convert into mass. So you from the number of atoms that you have to find out the number of mole, then to find out the mass, which is kind of like the opposite direction that we start with the mass and go into the number of atoms. So number of atoms going to mole, you're going to divide it by the Avogadro numbers. For the mole going to the mass, you're going to times it by molar mass. So by going through this, you'll find that the A would be 4.25 times 10 to 24 over 6.02 times 10 to 23. divided by Avogadro numbers times by the molar mass, which is 12 gram, and it will give you a answer. So the answer would be 4.25 divided by 6.02. I've got here, just the first part is 0.70598 times 12 gram. Just ignore that. Times it by 12 will give me 8.47 gram as my answer, right? Pretty much that's it. And I'll let you do water molecule yourself, which is like pretty much doing exactly the same situations. So yes, you should be able to have all the knowledge to finish up the two exercises I give you this week. The previous one would be the atomic theory. The second one would be just all this conversion between mole into number of molecule, from number of molecule into the actual mass, the given mass or whatever that we want to find. Play around with those equations and familiar with when do you need to use periodic table and when do you need to use Avogadro numbers. Okay, so hope you enjoy the exercise, and yeah, that would be done for today. Thank you.